Hi, this is the second video in the VEX VRC CAD tutorial series. In this video, we'll be going over how CAD works in VEX, how to create and bring parts into an assembly, and how to manipulate these parts. We CAD in VEX to be able to prototype different ways of building things. That way, we don't have to spend the time physically testing everything. For those who have done CAD before, you probably already know this, but for those who don't know, CAD follows the same rules as the real world. What I mean is that CAD is just as if you were building it physically, without worrying about wasting parts. For example, if in reality 2 holes don't line up perfectly, then you can still do it, but it might have to be off a little bit. Here in CAD, it follows all of that exactly. If a piece doesn't fit, we simply offset it a little bit. To put it simply, CAD is just another tool to help you build your perfect robot. One of the fundamental tools in Inventor is the constraint tool. This tool allows us to constrain 2 parts together, and with multiple constraints, stick 2 parts together so that neither can move. This is the main tool we will be using throughout the video. Another fundamental tool is the user interface. We get to this by right-clicking anywhere on a part, or even on the canvas. This pulls up a list of options that can be used to force certain rules on that part, or give us easy access to a certain tool. You'll use this often throughout the video, as some of the options are essential to CADing in VEX. One final thing is the orientation cube. This cube allows us to rotate our view around the part. When we hover our mouse near it, it becomes clickable and we are able to click and drag to rotate our part around. Also, in the top left of it, there's a little house, which if we press it, it'll go into the resting view, where we can see all 3 sides of the part. You will see me use this tool later, although I did not point it out at the time, so, in compensation, I'll call it out on screen. And now, let's get started. First off, we're going to make an assembly. In an assembly, we're able to bring multiple different parts in at once so we can start putting them together. To create an assembly, there's a simple button on the home screen. If you ever lose the home screen, simply pressing the little home button brings it up again. Down at the bottom, we can see what tabs we have open, and currently, it should only be the Home tab and Assembly 1 tab. If you ever double-click on a tab or the bar down here, it will go into multi-tab mode. And to get out of it, it will simply double-click it again. In our new assembly, let's bring in some parts to test our tools on. To do this, we're going to use the Place tool and find our part. For now, we're going to use 2 C channels, so let's get into our VEX library and grab some. Okay, once we open up the part, it'll show us a translucent image of it. And if we open the user interface by right-clicking, we'll get a couple different options to rotate the piece around. On the center of the part, 3 axes will show up, and those are the options to which the rotate tool refers to. If we were to rotate around the x-axis, for instance, then it would rotate like so. One thing not to forget is that the origin also rotates with the part. So what would have been rotating y might now be rotating z. Once we get 2 2x5 C channels in here rotated like so, let's begin learning the tools. So now that we have an assembly up and a couple of parts in it, let's go over all the different tools we will use. First, let's go over constraints. In CAD, we use many different types of constraints to force objects to use the same rules, but for now we're only going to use 4 different types. The 4 constraints we will use are mate, flush, axes, and insert constraints. A mate constraint forces 2 surfaces to oppose each other. It can be produced by choosing the mate in the solution box and then choosing 2 surfaces to mate to each other. Here I am choosing 2 surfaces on the top of the C channels. As you can see, those 2 surfaces snap together, and no matter what we do once we apply it, they will not be broken apart. You can move the C channels however you want, but no matter how you move it, or where you move it to, if you go back and look at it, those 2 are still mated right up against each other. A flush constraint forces 2 surfaces to be equal to one another. It is located in the mate type, and it has a different solution than the mate constraint. Here we are using the flush solution. Now, just like the mate constraint, we're going to choose 2 surfaces, and here I just chose the top surfaces again, and now when we look, they are directly equal to one another. No matter how we move these, those two surfaces will be right up against each other. An axis constraint forces two axes to become aligned. Finding it is a little bit more difficult than either of them because on our traditional menu right here, we can actually not find the axis constraint. Instead, we must choose an axis. Here, we take advantage of the imates, which will be explained in a few seconds. And you can see there's an axis going right through it. If we select that axis and another axis, those two axes are directly into one another now. They are aligned perfectly. But you can still move it around freely, and it will rotate along that axis. Before we go over insert constraints, we need to go over something called an imate. You don't really need to understand what an imate is, only what it does for us. Here you can see a ton of imates already, and it's just these translucent cylinders inside the square holes. They really don't have much purpose other than to make constraining stuff a little bit easier, as we're able to use axis constraints here, as well as insert constraints using these imates. And last but not least are the insert constraints. Insert constraints are probably the most important constraint we're going to use in this project, as they make things exponentially easier and saves us a lot of time. What an insert constraint is, it's basically like an axis constraint and a mate constraint combined. Once you select two axes in two directions, those axes become aligned and the directions become opposed as such. If we choose the insert constraint and we find an axis in a direction along with another axis in another direction, which they can be the same but they will oppose each other, so as you can see, those two directions oppose each other, the little arrow pointing opposite, and the axes are aligned. So when we go into front view, you can see that the faces are perfectly opposing each other, and when we go into top view, that axis and coincidentally that axis are perfectly aligned. It's still only on one axis though, so you can rotate around, and it becomes very, very important in CAD, especially VEX CAD, as it makes a lot of types very, very easily. You can simply just constrain two parts together, and after adding 2 points of contact, those two parts are now joined together. It was as easy as pressing 4 buttons. I think that was all that it took me. And yeah, that's all the constraints. One final thing I'm going to go over is how to ground an object. Grounding an object is when you cause an object to no longer be able to move about like this. Here you can see how it's moving freely, but if we open up the user interface by right-clicking, you get this long list, and down here we find the grounded option. If we press that, this part can no longer move. Others still can, but this part cannot. This is useful because when we constrain two objects together, like such, and we add multiple constraints, that object can no longer move because it is constrained in place, and this one is grounded. It becomes exponentially useful when you have a big assembly with hundreds of parts, where if anything moved, it would cause quite the issue. And that's all for today. Next time we will be CADing a chassis. It'll be a simple 4-motor, 4-wheel tank drive. It'll be using all the constraints we have learned so far, and that will be one of the last videos of this series.